write down the notes. Sometimes case arises the limiting value LV, that is equal to limit extends to a fx exists, and a functional value fa exists, and both are equals, and fa LV is equal to FB, then the function is said to be continuous, otherwise discontinuous. Write down another note 1, note 2. If a function is not continuous, if a function is not continuous, that is called discontinuous. A function is discontinuous in 4 cases. Discontinuous in cases 1. LV does not exist. LV does not exist, or FB does not exist, or LV and FB does not exist, exist, LV and FB exist, and but not equal, then the function is said to be discontinuous. So, in case of a continuity of a function, the continuity is tested at a given point or a particular point. Suppose that is note 3. First, in case of LHL, we have to take the less than conditions. In case of right hand limit, we have to take greater than conditions. Suppose the functional value, we have to take equal conditions, and a limiting value not equal conditions, that may be less than or may be greater than or may not be equals. Suppose at x is equal to a means we know that x or a, the point is given. Suppose at x is equal to a, we shall test the continuity or discontinuity of this functions at a given point a, that is limit extends to a, that is limit extends to a. We shall take an example. Test the continuity of the function fx is equal to sin 2x by x when x is not equal to 0, then whose value is equal to 2 where x is equal to 0 at the x is equal to 0. We shall test this continuity of this function at given point x is equal to 0. In order to test the continuity, we have to find its limiting value and a functional value. What is the limiting value? That is limit extends to the given point is taken as the limits, that is limit extends to 0. The condition is not equal condition. In case of a limiting value, we shall take the not equal conditions. The not equal condition, that is equal to sin 2x by x. There is a formula I have told you just earlier. Sin x by x equal 1, sin 2x by 2x equal 1, sin 3x by 3x equal 1, sin alpha x by alpha x equal 1. Therefore, sin 2x by x can be written as the formula as like this. Limit x tends to 0, sin 2x by 2x into 2. So multiplying 2 and dividing by 2, the questions remain same. Which this is equal to formula as limit x tends to 0, sin x by x, which is equal to 1. So 1 into 2, therefore limiting value is equal to 2. Then we shall find the functional value. What is the functional value? The function is equal to fx and limit is equal to 0. What is the functional value? Putting this limit at this function, we shall get the functional value. So x is equal to 0, putting x is equal to 0 in the functions, that is equal to f0. What is f0? When x is equal to 0, the value is given 2. So functional value is equal to 2 and a limiting value is equal to 2. Since limiting value is equal to functional value, therefore the function is continuous. The function is continuous at x is equal to 0 re. The function is continuous at x is equal to 0. Now we shall take another example. Test the continuity. Test the continuity of fx is equal to mod x by x when x is not equal to 0, value is equal to 0 when x is equal to 0, at x is equal to 0. In order to prove the continuity, but test the continuity, we have to find its limiting value and a functional value. The limiting value equal to limit x tends to 0. The function is taken as fx has two values, mod x by x and 0. The limiting value, in case of limiting value, the function is taken as not equal case, mod x by x, which is equal to limit x tends to, this is a modulus function. In order to find the limiting value, we have to test the existence. In order to test the existence, we have to find first LHL. The LHL of this limit, the left hand limit of this limit is equal to how much? Now limit x tends to 0 minus mod x by x, which is equal to limit x tends to, changing the limit x tends to 0, 0 minus h modulus by 0 minus h, that is equal to minus 1. And what is RHL? RHL is equal to limit x tends to 0 plus, that is mod x by x, which can be written as, changing limit as x tends to 0, so 0 plus h modulus by 0 plus h, which is equal to 1. Since LHL is not equal to RHL, since LHL is not equal to RHL, therefore the limiting value, that is limit x tends to 0 mod x by x, does not exist. Limiting value does not exist. Since the limiting value does not exist, so the function is said to be discontinuous. But the functional value is equal to how much? Functional value is given, f over 0 is equal to 0. Functional value exists, but limiting value does not exist. Therefore, the function is discontinuous at x is equal to 0. The function is discontinuous at x is equal to 0. Then we shall take another examples. Test the continuity. Test the continuity of a function fx is equal to 2x plus 1, 2x plus 1 if x is less than 1, and x if x is greater than x is equal to 1, and 2x minus 1 if x is greater than 1 at x is equal to 1. We shall test the continuity of these functions at x is equal to 1. In order to test the continuity, we have to find its left hand limit, right hand limit, and a functional value. Left hand limit is equal to right hand limit is equal to limiting value is equal to functional value, then is said to be continuous. So first, what is the limiting value? Always we have to find limiting value and a functional value. The limiting value of this function as limit extends to 1 and the function is equal to fx. The function is fx. So in order to find the limiting value, we have to find the left hand limit and also right hand limit. So what is left hand limit? The left hand limit as of this limit is written as limit extends to 1 minus fx, that is limit extends to 1 minus fx is taken as, in case of less than condition left hand limit, greater than condition right hand limit, equal condition रे functional value, greater than बड़े right hand limit, less than बड़े left hand limit, equal to बड़े functional value. ताले इन जेहेतु left hand limit नौ चंदी, so less than condition सिर्फ function टिक वामे नौ पढ़ियो, that is 2x plus 1. Changing the limit h tends to 0, which can be written as 2 into x is replaced as 1 minus h plus 1, that is limit h tends to 0 2 minus 2h plus 1, that is your limit h tends to 0 3 minus 2h, which is equal to 3. Putting the h as 0, we shall get the left hand limit as 3. Then right hand limit RHL is equal to limit extends to 1 plus limit extends to 1 thila. In order to take the right hand limit, we have to take limit extends to 1 plus. 1 plus means greater than 1. Greater than 1 condition रे function is equal to 2x minus 1. So changing the limit change करो, h tends to limit h tends to 0 लिखाओ, 2 into x का replace करो, 2 into 1 plus h minus 1, which can be written as limit h tends to 0, 2 plus 2h minus 1, that is equal to limit h tends to 0, 1 plus 2h, that is equal to 1. Since left hand limit is equal to 3 and right hand limit is equal to 1, so LHL is not equal to RHL, therefore limiting value does not exist. Limiting value does not exist. So the function is discontinuous. बुझेला? So the function is limiting value does not exist. and the function is discontinuous. Is it discontinuous at x is equal to 1? At x is equal to 1, the function is discontinuous. Another example, in a, suppose test the continuity. Test the continuity of a function fx is equal to bracketed x plus 2x plus 1 bracketed at x is equal to 3. At x is equal to 3. So the limiting value equal to here, limit extends to 3, the function is equal to 2x plus 1 bracketed, where bracketed x is equal to less than or equal to x. Bracketed x is less than or equal to x. Do you know the bracketed function we have read in first year? Perhaps forgotten. Suppose repeated just like for an example. Suppose 0.50 bracketed, that is equal to 0. 0.99 bracketed, that is equal to 0. 2.7 bracketed value equal to 2, but minus 0.7 bracketed is equal to minus 1. Minus 15 by 2 is equal to minus 7.5, that is equal to minus 8. Similarly, suppose h tends to 0, h is a very small positive number. Suppose h tends to 0, suppose 3 plus h bracketed value equal to how much? That is equal to 3. 3 minus h bracketed value is equal to, that is 3 minus 0 point something, that is 2 point something, which value is equal to 2. Suppose minus 3 minus h bracketed value, that is equal to minus taking common h 3 plus h, whose bracket value is equal to minus 4. That is minus 3 plus h bracket value is equal to how much? Minus 3 plus 0 point something, that is minus 2 point something, that is equal to minus 3. So we shall prove this as, in order to find the limiting value we have to find the LHL and RHL. LHL and RHL. Limit x tends to 3 minus and function is equal to 2x plus 1, changing the limit as x tends to 0. So 2 into 3 minus x plus 1 bracketed, that is equal to limit x tends to 0, 6 minus 2x plus 1, that is limit x tends to 0, 7 minus 2h bracketed, that is 6 point something, which value is equal to 6. Again RHL is equal to how much? Now changing limit x tends to 3 plus then 2x plus 1 bracketed. So changing limit as h tends to 0, 2 into 3 plus h plus 1, that is equal to limit h tends to 0, 6 plus 2h plus 1. So one limit h tends to 0, 7 plus 2h. 7 plus 2h, whose bracketed value is equal to 7. Since LHL is not equal to RHL, therefore limiting value does not exist. Since limiting value does not exist, so the function is discontinuous at x is equal to 3. Therefore, the function is discontinuous. Discontinuous at x is equal to 3.